Hello everyone, I am Nilav Yadav.
I'm Anshuman.
I'm Karmanya and I'm Agra.
We are the team members of AgroX and we are submitting our project under Samrid Bharat.
Namaste everyone. This is our robot Agrobot. The reason that inspired us to make this project was that in India, over 86% of the farmers own less than 2 hectares of land that make high-end mechanization unofferdable. And the major reason is that the digital divide. In rural areas, there is very less internet. Therefore, these projects are not reachable to them. Therefore, the solution of all these problems relies in an Agrobot.
I'll introduce Agrobot V1 and V2. These are multifunctional robots that do crucial tasks for farmers such as soil monitoring, seeding, irrigation to pest spraying and pest detection. They are truly evolutionary because they are affordable to farmer in less than 12,000 locally manufactured and no internet is used in the AI of this agro robot. They can communicate with these robots with their native language. That is why it is small. The Agrobot isn't a robot. It is farming success to the farmer.
Now for the hardware. Agrobot is made up of strong PLA material and also uses milliservo and gear systems for its expressive movements on the face. It also at the core of Agrobot is a Raspberry Pi 5, which runs a locally trained LLM model for personalized answers to the farm. It also contains an extra Arduino module which has a DHT11 sensor for temperature and humidity, a soil moisture sensor for checking the water levels in the soil, and a M2135 sensor for pollution checking. It also has a very rugged build, so it can be used in the agricultural commodities of Korea.
Moving on to the software, we have Raspberry Pi OS running on a Raspberry Pi and we have used Python as our main programming language. We have also used Ollama LLM. We trained a custom LLM named InMove LLM and we are using that. It has 0.6 million parameters, which is more than enough to answer the queries related to agriculture. In our V1, there was an LCD touchscreen which had predefined questions and it reduced the total questions which can be asked. But in this, we have a mic and mic records the query. This increases the number of queries which a farmer can ask to our robot. And moving on to the Arduino. Arduino sends the data to our Raspberry Pi and that data is saved in a JSON file. Our local model uses that data to give more personalized answer according to the soil of that village.
Now for the testing phase. We have accessed the Raspberry Pi to the laptop and everything is running on the Raspberry Pi and not the laptop. So now let's test.
Voice animatronic ready.
What crops can I grow in monsoon in India?
Rice, millets, maize, and various vegetables like cucumbers and okra grow well during monsoon season due to the abundant water supply.
So this is how a robot works. Thank you.
So we are planning to replace the Raspberry Pi and Arduino both with a single PCB to increase its cost effectiveness. We are also planning to put a silicon skin layer to provide more human-like interaction between the farmer and the robot, and we'll also use more accurate sensors so that our robot can provide more accurate details about the soil to our LLM.